Hello and welcome to How to Build in Web3. My name is Federico Ast. I am president at the Kleros Cooperative. In the last session, we reviewed some strategy notions and started building a link canvas for your project. Now we will start digging into another topic, which is network effects. So in the 1980s, the inventor of Ethernet, Robert Metcalfe, observed that the value of a network grows exponentially as more people join. If you are the only person with a telephone, then that doesn't have much of a use for you. But as more people join into the telephone network, so it becomes exponentially more valuable because there's lots more connections you can do with people, and this is how network effects grow. Crypto networks are basically networks of users that are coordinated by economic incentives. And why network effects matter and why should we care? Well, basically because there is a big difference between traditional software, proprietary software, and open source. In traditional software, companies can protect their competitive advantage by using copyright and using patents and that kind of things. But this doesn't work in open source because anyone can just copy the code. So, I mean, if anyone can copy the code, how can a project defend its advantage? And this is where network effects can work as barriers to entry in the open source industry. When copying the code is way harder than getting the users, and without the users, the network doesn't have much value, as we will see in some examples now. For example, in the case of Uniswap, the service becomes more useful with each new user because additional liquidity in the marketplace will result in better prices on trades. So if anyone could copy the Uniswap code, but if they don't have the liquidity, then the pricing will not be as good as the original platform. In the case of Compound, the protocol offers more competitive interest rates on loans as the lending liquidity increases. So you could copy the code of Compound, but you can't have the same interest rates because you don't have the liquidity in your new forked code. And in the case of Kleros, the protocol offers better and cheaper and more secure resolution as the pool of jurors is larger. So you could copy Kleros code, but if you don't have the jurors there, I mean, it's not going to produce good results for the customers. So the first step here is to try to understand the structure of the network you are going to be working on. So let's see a couple of examples here. For example, Netflix is an example of a single-sided marketplace where there are no network effects because there is a company selling a subscription to users who all have the same interest, they watching the content produced by the company. But more users joining the network doesn't mean that existing users will have any significant increase in the value they get from the platform. So they still have access to the same content, so that's why Netflix doesn't have network effects. In the case of WhatsApp, then this is a single-sided marketplace where all of the users, it's still true that they want the same to communicate with their friends. But in this case, there are network effects because as more users join the network, the higher the value each individual user will get because they can communicate with more people. So this is similar to the example we gave before about the telephone network. And then we have platforms like YouTube, that is a multi-sided marketplace with indirect network effects. So here we have different types of users. We have content producers, we have content consumers and advertisers, and each category produces value for the others. If you have more content producers, then there's more content for users to watch, and more users watching content means there's more opportunities for advertisers. So this means more advertisers bring more people wanting to produce content because there's more money to be made. And so this is how network effects work in an indirect network, where each type of user feeds other types of users, and this makes the whole network grow. This type of structure is very common in the sharing economy apps like Uber or Airbnb. In the case of Uber, you have two main types of users, like drivers and passengers. In the case of Airbnb, you have hosts and the home owners. So those are two different users that feed each other into the network. So the big questions you should ask here is, okay, when you try to understand the network, is who are the participants and what is the interest of each of the participants in the network. Okay, so now we have some basic understanding of the network, and now we want to develop a hypothesis about how the network effects work and what is the growth mechanism for the network. For example, in the case of eBay, we have basically buyers and sellers. So if there are more buyers, there is more incentive for sellers to join because there's more people who to sell stuff, and if there are more sellers, then there is more interest for buyers to join because there are more things to buy, and this loop feeds the growth of the platform. In the case of Uber, if we have more drivers, then there's going to be less wait times and fares for passengers, and then this will bring more riders to the platform, and this will mean that drivers can make more money and have less time waiting idle. This will bring more drivers, and more drivers means there's more interest for riders to join, and well, that's how the flywheel will start working. And in the case of Kleros, when we have more partners using the platform, this means there's more cases, and this means that there are there's more money to be made by jurors by resolving them, and then this will bring more jurors to the platform. This means that there's going to be better and faster and cheaper arbitration, which will bring more partners because the quality and the cost will be lower for them. And then this brings more cases and more jurors, and that's how we think about the growth of Kleros. So here you can just pause the video and think how the network effects would work in your platform, in your case. I mean, you can do type of graphic like this one, and you can write on the bubbles the different things that need to happen for the flywheel to start turning. And then we have a very important problem, which people typically know as the cold start problem, or other people call it the chicken and the egg problem. So in the early days, a network doesn't have much utility for the users, because if there are no sellers, why would a buyer want to join? And if there are no buyers, I mean, why would a seller want to join, right? So this is the problem of cold start that is faced by all of the platforms, basically, that are connecting different types of users. And in 2016, there was this very famous blog post by the Coinbase founder, Fred Ersam, and he suggested that a crypto could bring an innovative solution to this cold start problem. And this came from the fact that teams could give protocol tokens to early stage adopters. So in this case, to compensate for the early lack of utility of the network, because there are no users, projects can give a token to early adopters, and these early adopters, then they will want to join because they can have a big upside, financial upside, that will come from the appreciation of a token if the network becomes very large and widely adopted. So this gives them an incentive to join the network in the early days, even when the intrinsic utility is low. And this is when we can see that this works. I mean, in this chart you can see the total value locked in the case of two DeFi protocols, Compound and Balancer, and we can see how the TVL grows very, very fast since at the moment the protocols launch their token. So this obviously attracts a lot of users, and this can be used to solve the cold start problem. So a big important question we may want to ask is, can a token help us bootstrap our network? But it's not that simple. In this very good article, there is this VC called Samir Singh, who suggests that the idea of bootstrapping networks through tokens has some limitations. One good example is the case of the NFT marketplace Looks Rare that tried to compete with the leader OpenSea, and for that they launched a token. And on the first day, they had a very large amount of people using the platform because they rewarded people trading there with the token. But what happened is that right after the token reward program ended, they also saw the usage of the platform go down like very fast, because most users left immediately after the token rewards ended, which can be seen very clearly in the statistics of transactions. So this program was successful in attracting a type of user that was not really willing to stay for the long term. They were just there for the rewards and the quick buck. So it didn't create the expected network effects that the founders wanted to happen. So according to the Samir argument, token rewards tend to work better in networks that don't require an active participation of users. In the case of networks that do require users to be active and to do some type of work into the network, they tend not to work, and they tend to attract the wrong type of users, a type of user that are financially motivated and who are likely to leave as soon as the rewards are over. So when we're thinking about token incentives, two main questions we can ask is how to link the token to the long-term network utility, and how to make sure that tokens will go to the long-term users and not to those who are financially motivated. Because if we are not careful, we will get exactly what we incentivize, and what we incentivize might not be in the best interest of the network in the long run. So lots of things can be learned from people who know more about growing and scaling networks, which are basically Web2 companies. And those companies have succeeded into growing networks at a huge scale. So there are some things we can learn from them. And for example, in the case of Uber, we already saw that if there are no riders, then drivers will not join. But without drivers, then riders will have long wait times and the high fares, and they will not join. So what Uber did in the early days was to just hire professional drivers that riders could hire through the app. And so this gave it was good for starting the network in the early days when they faced the cold start problem. And so things like this could be also part of a strategy that we use in order to bootstrap a Web3 network. Something similar was done by the founders of Reddit. In the early days, they didn't have any users, so nobody was writing there. So why would people go there to read if there's nothing to read? So the founders spent much time writing articles and writing posts, so people would join and then see there's content, and then there's an incentive to use the website. And then after the users reach some scale, then there is network effects start growing and working, and so founders can just stop doing the post and just leave it to the users. So lots of ideas on how to scale a network can be found in this great book called The Cold Start Problem by Andrew Chen. This will teach you how to analyze the structure of a network, how to think about different strategies to make the network grow. Homework one for you is to first understand the structure of your crypto network and the incentives of participants. The second homework is to develop a network effects hypothesis. And the third homework is to plan how to bootstrap your network based on what we just saw. Okay, see you on the next lesson. Bye-bye.